Assalamualaikum and hi everyone. Jadi sesi kali ini kita akan lihat presentation para pelajar yang akan berkongsi ilmu bersama kawan-kawan bagi persediaan menghadapi final exam yang bakal tiba dalam sesi Dari Kita Untuk Kita. Jom kita tengok.
Hi, Assalamualaikum and Selamat Sejahtera. My name is Putri from S50B6. So today I'm going to discuss with you guys subtopic 2 for chapter 5, which is 5.2 Energy and Conservation of Energy. So in this subtopic, I'm going to discuss the learning outcome, which is A, B and C. So A, we have define and use potential energy. So basically, potential energy, we have two types, which is gravitational potential energy and elastic potential energy for spring. Then, the second one is B, define and use kinetic energy. And C, state and use the principle of conservation of energy. Okay, first of all, we have to know that what is energy. So, the definition of energy is the system ability to do a work. So basically, when there is work, so there is energy. And unit SI for energy is joule. Energy is a scalar quantity because there is magnitude only. We don't have the direction. We move to the gravitational potential energy, which is U. Okay, the definition is the energy stored in a body or system because of its position. So basically, the energy in a body, it depends on its position. So the equation for gravitational potential energy is U is equal to mgh. M is mass of the object, G is gravitational acceleration, H is height from its initial position. So gravitational potential energy ini depends on the height of the object above the surface of the earth. Okay, so this is second type of potential energy, which is elastic potential energy, defined as US. So what is exactly elastic potential energy? Okay, for me, to make it easy, elastic is a material that we can compress and stretch, right? So when the material can compress and stretch, so there is a work. So when there is a work, we can find the energy stored in the elastic material. Itulah maksud dia. Okay, then elastic potential energy obey Hooke's law. So what is Hooke's law? Say that the restoring force of spring is directly proportional to the amount of stretch of compression. Okay, if the limit of proportionality is not exceed. So this is the restoring force proportional to the amount of stretch. So okay, from the Hooke's law, we can get the equation is Fs is equal to negative Kx, which is Fs is the restoring force, K is the spring constant, and X is the amount of stretch or compression. The negative sign indicates that direction of Fx is opposite the direction of the amount of stretch or compression. So maksudnya, contohnya when we have initial condition right here, and this is final condition. Okay, initial and final. Okay, so contohnya when elongation is to the right, so the restoring force is to the left. So that is why the equation have negative. From the Hooke's law, without the negative sign, we can get a restoring force against extension of the spring graph. So from the graph, we can get W, which is area under the graph. W is work, so we can get from the area under the graph. So area under the graph is 1/2 Fx squared. Okay, so F is you know that F is equal to Kx. So we substitute into F, so we get 1 over 2 Kx multiplied by X. And then we get 1 over 2 Kx square. So 1 over 2 Kx square is actually the formula for elastic potential energy. Okay, so this is the formula of elastic potential energy. Okay, so basically we have 1 over 2 Kx squared or 1 over 2 Fsx. So cara kita nak guna dia, it depends on the equation. So contoh bila the equation give us spring constant, we use this equation. When the equation give us a restoring force, so we can use this equation. Okay, so we move to the second learning outcome for 5.2, which is kinetic energy. Kinetic energy. So kinetic energy is the energy of a moving object. So when the object is moving, so we can find the energy of the kinetic motion lah. And the kinetic energy is depends on mass and velocity. Okay, the equation for kinetic energy is, this is K. 1 over 2 mass multiplied by V squared. Okay, so this is the last learning outcome for 5.2, which is principle of conservation energy. Okay, so principle conservation energy ni adalah it states that energy cannot be created or destroyed. It transforms from one form to another. Okay, so apa maksudnya energy cannot be created or destroyed? So maksudnya macam ni. Total energy initial is same with the total energy final. Sebabkan kita tak boleh destroy the energy, so the total energy initial is same with the total energy final. Okay, energy transform from one form to another. Okay, so ni adalah contoh energy transform from one to another. Okay, macam ni. You know that we can get potential energy in this object because we have height. Okay, when we have height, so this object has potential energy. So basically, contoh lah kan, bila kita cut this rope, so the object akan jatuh. So daripada potential energy dia tukar jadi kinetic energy, sebab from this dia jatuh, so dia ada motion kan, so when the object have motion, so dia ada kinetic energy. Okay, so basically this lesson is not complete with that question, so I prepared for you guys a few questions for 5.2. So question 1 state that a force of magnitude 800 Newton cause an extension 20 centimeter on a spring. So for me, I will take out the information given. So force given is 800 Newton and the extension is 20 centimeter. We have to convert into meter, so we get 0.2 meter. So the question asks us to determine the elastic potential energy of a spring when the extension is 30 cm. So first, to make it easy, we have to know what is the equation for elastic potential energy. So we have US is equal to 1 over 2 Kx square. Okay, so sekarang ni we have the extension. Kan is the extension given, but we have to find the K. Okay, so how to find the K? Kan dia dah bagi restoring force, so basically restoring force is equal to Kx. So from this we can get K, so we just substitute the value into the equation. So force is 800 Newton and X is 0.2. So we get K is equal to 4 times 10 to the power of 3. So this is the unit. Okay, don't forget the unit, Newton meter per second. 800 equal to K 0.2. Okay, so 800 is Newton and 0.2 is meter. So we get that. We get K is equal to Newton meter per second, like that. So we get like this. Okay. Okay, so after we get K, which is spring constant, so we can finally substitute the value into the equation. So 1 over 2 times K spring constant, kita dah dapat 4/10^3. X integration, when integration is 30 cm, so we have to convert into meter. So we have 0.3 times power of 2, and then we get 118 joule. Okay, that's it. Okay, for question 1b, the question asks us to find elastic potential energy when a mass of 60 kg is suspended vertically from the spring. So which means the ball is 60 kg. So when we look at the elastic potential energy, we have 1 over 2 kx squared, right? So basically we already find the K spring constant, but the equation is not the elevation is not given, right? So we have to find the x. So the information given is 60 kg. Okay, bila spring to in equilibrium condition, so we know that when the object is equilibrium position, so the total force is 0, right? Okay, when the total force is 0, we draw a body diagram. So this is the body diagram. Starting force upward and the weight is downward. Okay, so before this step, we have this like this. So starting force minus weight is equal to 0. So we take out to the right, and then we get like this. And then we know that Fs is equal to Kx. So we can find x. We just have to take the value. So we bring to the down. So divide by K. So we get x is equal. So mass is 16 kg and gravitational acceleration is 9.81. So we get the elongation is 0.147 meter. So elongation is meter, okay? So therefore, bila kita dah dapat all the value for K and X, so we just substitute into the equation. So we have K from the previous equation. K is equal to 4 times 10 power of 3, and X we get 0.147 squared. So to calculate, use calculator, so we get 43.2 joule. Okay, so we move to the second question. The question is, a block of mass 2 kg slides 0.75 meter down an inclined plane that slopes downward at an angle of 36.9 degree below the horizontal. So if the block starts from rest, calculate its final speed. You can ignore the friction. So first of all, when we read the question, we have to know what is exactly the question want. So dia kata question asks us to calculate its final speed. Okay, ni kita tengok block start from rest kan. So we have U is equal to 0. And then this will calculate final speed. So final speed kita V. Okay, so in this chapter, when a block is moving down, so there is kinetic energy. Okay, so first of all, we have to draw a free body diagram to make it easier. Okay, so we draw free body diagram. Here we are y-axis, we have normal force. Okay, then we have weight sebabkan incline plane ni dicondong, so weight kita kena ke bawah like this. So we have weight, and then here we have dia kata we have so we have, dia dah bagi dekat sini, downward an angle 36.9 below the horizontal. So bila we have angle here 36.9, so the angle will be here. Okay, so we get like that. Okay, so this is the solution. Okay, given us mass of the block is 2 kg, and then the displacement, maksudnya block tu dia turun 0.75 meter, and the block is from rest, so initial speed dia adalah u is equal to 0. Okay, so since the motion of the block along the inclined surface, okay, so basically the block is moving above the inclined surface, so dia bergerak in x-axis kan. So bila dia bergerak in x-axis, so we have to find the total force from x-axis. So force net is equal to mg sin, sebab angle is beside the y-axis, so that's why kita guna sin. Okay, and then mg is the weight of the block. So mg we have, okay, so mass is 2 kg, g is gravitational acceleration 9.81, and then sin 36.9. So we have total force for x-axis is 11.8 Newton. Alright, so by using the word kinetic energy theorem, thus kita tahu total work is equal to kinetic energy final minus kinetic energy initial. So from this, so they become like this because we know that work is equal to Fs. So bila kita dah dapat total force and with displacement pun dah diberi, so we just substitute lah the value. Okay, so kinetic energy is 0 sebab initial speed dia 0. Dia start from rest, so initial speed is 0, so kinetic energy initial is 0. Then we can calculate the final velocity. So total force is 11.8, displacement is 0.75, okay, 1.2, mass 2. Okay, so bila kita pindah-pindahkan ke calculator, we can get 2.98 meter per second. So we just answer the question. Okay, so this is the last question. Okay, a bullet of mass, which is kita jadikan bullet ni as a mass 1, which is 5 gram, is fired into a wooden block of mass. Wooden block ni kita define it as a mass 2, which is 1 kg. Wooden block of mass is 1 kg, suspended from some light wires as shown in figure. The block initial at rest. The bullet embeds in the block and together swing through a height 5.5 centimeter. So the question asks us to calculate the initial speed of the bullet. Okay, so to have a better understanding, so I try to divide into 3 conditions, which is first, the bullet is going to the wooden block, okay, and then the bullet is embedded into the wooden block, and the wooden block is moved to the certain height. So basically, this is application for principle of conservation of energy. Sebab first dia at rest. So when at rest, then the bullet is embedded into the wooden block, so dia bergerak. Dia menyebabkan wooden block tu bergerak. So bila wooden block tu bergerak, automatically there is energy, kinetic energy. Okay, from this we have kinetic energy. And then the wooden block is dia bergerak at a certain height. So above the surface of the earth kan. So we have gravitational potential energy at a certain height. So from kinetic energy, so from the kinetic energy, then we have potential energy. Alright, so we have to apply the principle of conservation of energy. Okay, first we have, principle of conservation of energy state that total energy initial is equal to total energy final. So kita ambil because the question asks us to find the initial speed for bullet, so we take condition 2 and 3 sebab dia ada conservation of energy. And then okay, so total energy condition 2 is equal to total energy condition 3. So at condition 2 we have kinetic energy, and at condition 3 we have potential energy, which is U. So kita boleh je lah masuk dalam equation. So 1/2 mass yang berbeza tapi initial speed adalah sama-sama. So we have same initial speed lah kan. Okay, so 1/2 mass 1, which is the bullet, plus the mass 2, which is the wooden block, and then initial speed 1/2 because of the wooden block and the bullet punya speed kuasa 2, and then equal to the potential energy. So potential energy is equal to mgh. So mass kita adalah mass yang berlainan, so mass bullet plus mass wooden block, gravitational acceleration and height. Mass 1, so mass 2 kita boleh potong. So kita tinggal bawa pergi sana, 2 ni bawa pergi sana. So we have 2gh and square root and power of 2 kita bawa pergi ke kanan, we have square root. So that's why kita dapat macam ni. Okay, so 2 G is gravitational acceleration. We know that 9.81, and then height at a certain height given is 5.50 centimeter. We have to change into meter, so we get 5.5 times 10 power of -2. So finally we get initial speed is 1.04 meter per second. So that's it for me. Okay, so that's it from me. Thank you for your time to watch this video, and I hope that you guys can have a better understanding after watch this video, and good luck for your PSPM. Okay, bye bye. Assalamualaikum.
Okay, so topic 5, there is subtopic 5.2, which is work energy theorem. So the general equation for the work energy theorem is W net equals to delta K, which is to net work is equals to the change of kinetic energy. So the change of kinetic energy is final kinetic energy minus initial kinetic energy. So how do we get this equation? We get it from the derivation of these two equations, which is the first equation is F equals to ma, and the second equation is V squared equals to U squared plus 2AS. And if we substitute equation 2 into equation 1, we get that F net is equals to m bracket V squared minus U squared over 2S. And if we complete equation, we get that F net S is equals to half mv squared minus half mu squared. And actually this half mv squared is equals to kinetic energy, and V is final, U is initial, so we know that half mv squared is k final, kinetic energy final, and half mu squared is the initial of kinetic energy. So the work is force times displacement is equals to the change of kinetic energy, which is kinetic energy final minus kinetic energy initial. So work energy theorem states that the work done by the net force on a body is equals to the change in the body's kinetic energy. So when W net is positive, the kinetic energy increases. The final kinetic energy, Kf, is greater than the initial kinetic energy, Ki, and the particle is going faster at the end of the displacement. When W net is negative, the kinetic energy decreases, Kf is less than Ki, and the speed is less after the displacement. And when W net is 0, the kinetic energy stays the same. You can see here is K initial is equals to K final, and the speed is unchanged or constant. Okay, so here is an example of the work energy theorem. Okay, so we first read the question first. A 70 Newton force is applied horizontally to a 10 kg block at rest for a displacement of 200 meters across a frictionless surface. So the first question is how much work is done by the force. B, what is the final kinetic energy? C, how fast is the block moving? D, what is the acceleration of the block in the horizontal direction? Okay, so for the first question, how much work is done by the force? Okay, so before that, we look at the question. We must take out the information given. And see here that the information given is 17 Newton force, 10 kg block, rest, displacement of 200 meter, and frictionless surface. Okay, so the general equation for work is, so A, work is equals to F S. So this is actually a direct question here. So the force is given here 70 and the displacement is 200 meters. So we put in so 70 times 200, we will get 14. We will get 14,000 joule. Okay, so this is for the first equation. So we move to the second equation, which is B. What is the final kinetic energy? So final kinetic energy, first we write the general equation, which is W equals to K F minus Ki. Okay, so to menyelesaikan soalan B, first we must untuk lebih faham, kita lukis dulu situation dia. So just draw a straight line. There is a block here with 10 kg and a 70 Newton force is put here, and the block will move 200 meter. So what will be here? So this is A initial and B final will be here. Okay. So what is the final kinetic energy? We know that this block here is at rest. At point A, the block is at rest. So if at rest, there is no acceleration, no velocity. So the initial will be, we write here, half mv squared minus half mu squared. So this u here is 0. So we can cancel off. So actually the work is equals to the final kinetic energy. So just now the work is here is 14,000 joules. So kinetic energy final is actually the same, 14,000 joules. Okay, so we move to the third question. Yeah. So see, how fast is the block moving? So fast is actually, we know that first we must find the velocity. So just now, how fast is the block moving? So we know that the initial is 0. So we must find the final velocity, which is k final equals to half mv squared. So just now from the question B, we know that the final kinetic energy is 14,000. So equals to half, the mass is given here, which is 10 kg. So we want to find the V here, V squared. So complete 1 by 1. Half of 10 is 5 squared. So V squared, which will be 14,000 over 5. Okay, so V squared is equals to 4,800. So V is equals to 52.9 meter per second. So this is the answer for C. Okay, so for question D. What is the acceleration of the block in the horizontal direction? So you want to find the acceleration. You can find this acceleration from the equation of F net equals to ma. So here the F was given because it is on a frictionless surface, tadi geseran. So force, net force here is 70. equals to, the mass is 10 kg and acceleration here. So the acceleration here is equal to 7 meter second. 7 meter per second. So we're done for all of this question. So question 2. For the first question, how much work is required to accelerate a 1500 kg car from 15 meter per second to 40 meter per second? Okay, so how to complete this question? Kita guna general equation, which is work kan. Question asks how much work. So A, work equals to kinetic energy final minus kinetic energy initial. So if we look at the question, there were given the mass here and the velocity, initial and final velocity here. So kinetic energy is equals to half mv squared minus half m u squared. So the mass is given, so we just substitute in. Mass is 500 from 15 meters second is initial, so the final is 40 squared, don't forget here, minus half 1500 kg and 15 seconds squared. So the answer is equal to, okay, so we just substitute and just write in calculator, and the answer will be 1 liter 0.1250. So yeah, the unit here is joule. So this is the answer for question A. And question B, what is the average net force acting on the car if it reaches a final speed of 40 meters per second while traveling a distance of 275 meters? So how do we complete this? So the question minta net force. So we can just easily selesaikan soalan ni dengan soalan B dengan menggunakan equation W equals to F as, okay, so it's the same right here, and so the work just now is 1 million 250 equals to the F net, and the displacement is 275. So we can actually get this easily by dividing 101 1031 250 with 275. The answer is 3750 Newton. Okay, so that's all for subtopic 5.2 work energy theorem. Thank you.
Assalamualaikum and good morning everyone. My name is Nur Anissa Zulaika binti Anwar and today I'm going to present about physics chapter 5 under subtopic 5.3 which is about power. Define and use average power and instantaneous power.
There is two types of power, which is average power and instantaneous power. Average power formula is as stated, and average power is defined as the work done or energy per unit time. Instantaneous power, also known as stated, and instantaneous power is defined as the instantaneous rate of doing work. So now consider an object that is moving at a constant velocity v along a frictionless horizontal surface and is acted by a constant force, capital F, directed at angle theta above a horizontal as shown in figure. The object undergoes a displacement of ds. Therefore, the instantaneous power P is given by V equals to Fv cos theta or P equals to F naught V, where V equals to magnitude of velocity, F equals to magnitude of force, and theta equals to angle between F and V. Equals to For the first question, an elevator has mass of 2.0 mg and is carrying 20 passengers through a height of 10 meters from the ground. If the time taken to lift the elevator to that is 40 seconds, calculate the average power required by the motor if no energy is lost. Use average mass per passenger is 50 kg. By using the given information, we can get the small m, which is mass of the elevator plus mass of 20 passengers, and substitute the value, we get small m value, which is 2800 kg. And using the related formula and substitute the value, so we get the answer. And moving to the next question. On a highway, a driver increases the speed of his car from 60 meters per second to 30 meters per second in 10 seconds. If the total mass of the driver and the car is 2.5 times 10 exponent 3 kg, what is the average power needed? To solve this question, we need to find the work done, which is work done equals to change in kinetic energy. And by using the formula of change in kinetic energy, which is half mv squared minus half mv squared, and substitute the value, we get the work done value. And after that, we use the work done value to get the average power. And by using the formula of average power, which is total energy over total time, we get the value of average power. For the third question, a 700 kg lift is moving upwards for 4.0 seconds with constant acceleration until it reaches its final speed of 16.0 meters per second, and given 1 horsepower equals to 746 watts. Find the instantaneous power in horsepower HP of the motor at t equals to 4.0 seconds. To solve this question, we need to use the power formula, which is P equals to Fv, and substitute the value of F and V, and we get the answer of power, which is 60.1 horsepower. That's all from me. Thank you for watching my video.